Good morning, everyone. So it's really great pleasure for me to represent our transformational Whirlpool transformational journey across this board. So it's really great pleasure for me to represent Whirlpool transformational journey on virtual product development on this platform. So thank you, Zinnov team, for hosting this event. So as mentioned, I'm going to talk about virtual product developments. Maybe you can go to the next slide. So on higher level, I'm going to talk about what Whirlpool Corporation is, so including our product range. Then what are the challenges we have, that is market demand. Then I will just brief about our product development process. And then with current product development process, how we are moving or how we are transforming for the virtual product developments. And then there will be some examples with how we are moving our journey, and followed by some of the challenges and where the future state would be. So with that one, let's move to the next slide. So Whirlpool Corporation, it's an almost 112-year-old company. It was started in 1910 in city Benton Harbor, Michigan State, USA. So today it's one of the leading manufacturing home appliances industries. So if you see, it's a constantly ranked in top 200 Fortune 500 companies. So company which has more than 100 years and continuously be a part of 500. I think it's one of the unique home appliances industry in that range. So Whirlpool is among the 10 most innovative organizations. Worldwide, we have more than 78,000 employees. Across world, we have 70 manufacturing centers and technology and research centers. So approximate our sale in 2021 was 22 billion. Last year, it was a little bit down, around 21 point something, but it is in that range. And overall, we have 12 brands as a part of global portfolio. So we operate more than 170 countries around the world. So you can understand the scale and the complexity or in the globalization of the Whirlpool corporations. So it's not about only the numbers or business. It's moreover how well it is recognized by the different, or it got the testimonies from the different agencies as for the employees. So first one is Great Place to Work by Great Place to Work organization. So every year they conduct the surveys across the industries, and last 5 years they are recognized Whirlpool as one of the great place to work. Top 25 best places to work in manufacturing sector for last 3 years. Best in consumer durable industry for last 2 years. And top 25 great place to work for women for last 2 years. So these are the testimonies we are getting for our employees, the kind of culture we have, kind of well-being we have in the organizations, and kind of career growth we have in the organization regarding our employees. So let's talk about which are the different products we have across the globe, because I know Whirlpool in India is mainly known for refrigerators and some of the laundry product, but it's not that. There are basically 4 major verticals we have. First one is cooking. So under cooking, we have freestanding range. So different ovens, cooktops, and duo, combo. So there are different products under freestanding range. Then built-in range, we have cooktops, microwaves, and there are different other products under cooking. Second major verticals is the refrigerations. In India, we have good presence in single door, double door, partly 3 doors, and very small market on the 4-door refrigerators. But in North America regions and other regions, it's more your side-by-side French door bottom mount, because French door bottom mount, it's a large capacity refrigerators, which is quite famous in North America regions. And other refrigerators, they're quite famous in Europe as well as in Latin America regions. Third vertical is regarding laundry. So under laundry, we have horizontal access machine, vertical access machine. You know, vertical access is quite famous in India. Now, horizontal access washing machine called as a front loader, that is also growing the demand in India. Dryer, it's a product particularly in North America region, because we cannot just sell washing machines. So with washing machine, we have to sell the dryer. Dryer is an essential part of that one. And now we have come up with where we integrated washer and dryer called as a combo. So this is quite famous product in Europe as well as in North America regions. Last vertical is regarding dishwasher and small appliances. I know after pandemic, even in India, demand for dishwashers is increasing, but we have very good market in North America region and EMEA regions. India is growing up, but definitely that penetration required a little bit more time. Again, small appliances, which is not known much, because we have high-end brand called KitchenAid, and under KitchenAid we have different products like toaster, grinders, mixers, across the globe. But it is one of the top-notch brand what we have under small appliances. So this is all about different product portfolio what we have, and these are the major products. Apart from that one, there are multiple products like an AC and other things. With respect to our context, I will just go with major product and how that journey is transforming for the major product. So that's global view. Now, what is there as a captive? Okay, so our captive center is in Pune, that is called as a Whirlpool Global Technology and Engineering Centers. So this is the only integrated center for technology and engineering outside US. Okay, when I'm saying integrated center, in the sense we do support product development, we do support simulations. There is much things which we are developing for in IT zone, and also in supply chain or global business solutions. So everything is in one umbrella. So that is the only one center where all these things, all cross-functional things are here. So we started this journey in 2004. So it's almost 20 years of growth. Currently, we have more than 950 engineers working across different technologies and different product development areas. This center is more your innovation focus. So till date, we have more than 300 plus patent filed. So last year itself, by 2022 numbers, if I go, it's more than 90 patents we filed from this center. And if you go by percentage of patent files across Whirlpool, so more than 35 to 40% patents or more your innovation is coming from the centers. So it's one of the innovation focused centers for Whirlpool. And in terms of employees, again, ranked consecutive 4 times in a row that one of the best place to work by the Great Place to Work organizations. So this is about what this captive center is. Going to the next slide. So what we do, so I'll just go a little bit deep. So what we do at these centers. So as I mentioned, we are a part of global product organizations. So in terms of product design, we do conceptualizations and detailed design. Maintenance of the business, that is in terms of cost projects, take out the cost, reducing the quality or improving the quality, reducing the SIR, so cost and quality for all product category. Next vertical, which again, which concentrated today's topic like virtual product development. So simulation-based design is a part of that virtual product development. So we do have the capability in structural simulation, flow simulation, noise, manufacturing, optics. We'll discuss more in detail in subsequent slide, and multi-body and multi-physics dynamics. Next vertical under product development is electronics and software, where embedded software, hardware design, and majority of verifications and validation for the software is doing from this center. Another vertical is information system, because we know India, we have good talent for IT areas. So all IoT and mobile apps, most of the appliances nowadays is connected appliances. So that connectivity, mobility, data analytics, mobile apps, all this development and support, we are doing it from this center. Last vertical, that is supply chain or global business solution, that is enterprise solution. So all kind of business analytics, manufacturing solutions, including manufacturing simulations, is a part of this vertical. So in short, this is what we do it in our captive centers. So because we are going to talk more about virtual product development, that is a simulation team. So just wanted to give the glimpse about what kind of a CE team or simulation team we have. So this is largest CE team within Whirlpool collaboration. So in Whirlpool Corporation. So it's more than 75% of global team is sitting, or center of gravity is in GTEC or Pune. So we have highly skilled and innovative team dividing product attributes like core performance, energy, noise, manufacturing, assembly, aesthetic, and whatever required for our product development. So it's a complex physics-based system model integration with simulations. It's highly integrated with all product development, what is required for Whirlpool across the globe. And it's highly synergized to deliver the maximum value to our product development team. So ensure timely insight and robust design to reduce the physical testing. So this is just brief about what this simulation team is. Okay. So with this background, let's touch base to the today's topic. Go to the next slide. So what are the challenges we face as an industry? Okay, maybe keep on clicking on that one. So first one, what is requirement? What is demand? What are the challenges we are facing it from the organization? So first one, first in market, what it means. If we launch any product, if we are first in market, we are getting that edge. Otherwise, If we are a follower, nobody follows us. In the sense, nobody wanted to have the same replica of the product in the market. So we should get that edge. Second challenge or second requirement is multiple solutions. Now, for example, Indian market. So till date, we have say vertical axis washing machines. There is a demand for horizontal axis washing machines, and most of the demand, when we go through the consumer survey, we saw that okay, 7 kg or 8 kg machines has a maximum demand. So we cannot just go off one variant of 7 kg horizontal axis or front loader washing machines, because there are different consumer and there are different set of consumer and they have different requirement. For example, some people, they they are tech savvy, so they wanted to have all things connected with the mobile. Okay, so some they want connectivity, some they said no, we wanted to have manual operations. Some they said I wanted to have knob operated things, some said no, I wanted to have touch base. Okay, some have different color options. Okay, some they wanted to have different finishing of the product. Okay, so there are different requirement of same machine, so we cannot just go with single solution, so we have to go with the multiple solutions. So this is when we just consider one type of market. But when we see the industry, because Whirlpool is in global organizations, so there are different norms across each region. Okay, so for example, in terms of electricity supply, we have say 330 volts. Other regions are 110 volt with 60 hertz with different frequency shift. Okay, their norms are different. In terms of energy, they have different requirement. In terms of safety, they have the different requirement. So though we are building a same machine, but as per their norms, we need to have the multiple solution which can address all these needs. Then everyone want good quality with highly reliable product, because day in and out you're using that product for a longer time. So we say at least 10 years we are using that product. So everyone wanted to have reliable and good product. Then people are looking for the innovative solutions. They just don't want what is there in the market, but they wanted something new. How we are creating, how we have putting the creativity in the product. Everything they wanted to have the competitive cost. And now considering overall environmental effect, everyone is looking for sustainability of the product. So this is what we are looking from the market perspective or different challenges we have for the product development. So what is the impact on the product development? So if you wanted to have first in a market, yes, you should have shorten product development times. How quickly you can convert the concept into the product. Okay, previously it may take like 3 to 4 years. We wanted to within 8 to 10 months wanted to develop the product and bring it to the market. We need to have different design options, not with single options, but different options. Okay, with 7 kg machines, take this as static. You have mobile apps, you have connectivity. It's up to consumer to select it, what they want. To have the good quality product, it should be properly verified and validated product. At the same time, it should be an innovative product. There should be some creativity. There should be something new in the product. Then only consumer will focus on your product. And everything should be at the best cost, and it should be a sustainable product. Okay, sustainability is completely a big topic, but even for the virtual product development, it's a key to understand and drive that requirement. So that's overall complexity or the requirement what we have in home appliances industries. So what is solution for that one? So as I mentioned, it's a global organizations. Okay, so we are developing the product for the different region. Okay, so regional wise there is variation. Regional wise there are different requirement. Regional wise there are different codings. So how do you manage all this kind of a complexity? Okay, over here now new norms have come. Design globally and manufacture locally. Okay, so if I'm designing the product which is required, say for Latin America region, how that consumer need is. Okay, how do you understand whatever I'm designing, it's as per the requirement of what is need in that market. Okay, so that's what we are going with system engineering approach, which is more a transdisciplinary and integrative approach using system principle and concepts. I know most of you are aware about this V. So it starts with what is consumer requirement, what consumer want. Okay, so you get this data by other consumer research, understanding the market trend, or there are some predictive analysis or predictive team working on understanding in which direction market is moving, what people are looking for. Okay, sometimes people don't know what they want, but in terms of technology trend, they do understand and they come up with, okay, These are the things which are required for the new consumers. So how do you capture this requirement? So that's most important. Once you capture this requirement, how you convert voice of customer to the voice of engineers, that normally in engineering term what we call as VOC to VOE. Okay, so once you convert into the engineering requirement, based on engineering requirement, how do you define what kind of system you wanted to have? Okay, what kind of architecture you wanted to have? Okay, so whether you wanted to have different architecture or you wanted to have different solutions. So that kind of a clarity you should get it from this kind of all discussions or requirement specifications. If you end up with multiple architectures, higher multiple architectures will again increase the complexity, and also management of this multiple architectures again creating a lot of issues, and also managing such a complexity is become very tedious topic. So we should have the clarity how we can optimize the architecture. Then how can optimize the design systems or subsystems, and then how you can decompose the requirement to the component level. Okay, so this is all about what is required at the down level. Okay, then it start implementations. So everyone is quite good in design and development, and after development on the right side of V is more about verification and validations. Okay, so whatever it has come on the say component level, whether you have the right system to verify it, either it's a test lab, either it's doing say testing in a lab, or it's virtual, or whatever it is. But do you have the right system? And then you are making sure that you have verified the right requirement, what is coming down or what is nailed down to the bottom level. Same thing for subsystem level, architecture level, and then moreover you defined or you can cross check whether it is invalidated things, means whatever is required that you are giving it back to the customers, that need to validate it at the system level. Okay, so I know most of you are aware about this V, but why it is important? Because as I mentioned, there are certain requirements coming from different regions. Okay, you don't have insight what kind of a consumer they are. Okay, out of this product development type, you are getting the requirement in bits and pieces. For example, they ask us to develop some systems. They may ask something to develop on say IT area. They ask us to develop something on say connectivity. Okay, so this is not a full end-to-end development. It's aware to you, but moreover, it's bits and pieces that information is coming to you. There are certain asks that organization ask you to do it. Okay, but one is what is defined, you can definitely deliver. But if you don't know what is there, what is the impact of your deliver on our consumer requirement, unless and until you have that clarity, you cannot deliver the value which is required for the consumer. You can deliver what is asked for, but you cannot deliver the value what consumer is looking for. Okay, that's what like system engineering approach is very much important. So when it was completely physical, it was quite difficult to understand what is their need, what is requirement at system level, subsystem level, architecture level, and again satisfied. So it was quite difficult. But because of this digital transformations, and as we are moving more on virtual side, it's quite easy because there is a consistent language. Okay, so for example, there are certain things which is defined at say architecture level. How the person sitting in different region who has some engineering knowledge, who can understand this is requirement. Okay, again, it's not only about the engineering, but it's more about cross-functional collaboration, customer requirement, everything. Mostly all marketing people, they are a part of it. VOC to VOE, it's more your marketing people, engineering team, manufacturing team, finance team. They are sitting together, and then they are defining, okay, what kind of a system we required. Okay, what is architecture level required? So it's more your architecture lead, and when it comes to the subsystem lead, it's more your subsystem lead, and then it comes down to the component level. Okay, so sitting at one region, when they define it, how well, how consistently their language, so that when I'm verifying the system or when I'm working on any kind of a design, I should have the same clarity what they want. So there should be a proper system to understand the requirement, and there should be a consistency so that same message, same requirement has to percolate at different level. For example, somebody is wanted to have the verification at any component level. He should be able to understand what is that component level specifications, what is or where that component is going to sit in subsystem and where that subsystem is going to sit in overall system, and what is that value I'm giving out of it to the consumer. So for that one, it's very much required that we should follow the system engineering approach. Now coming back to virtual product development or virtually. So initially it started with the implementation phase. Okay. So previously it was more your two-dimensional drawing or 2D drawings, and then now it is moving to the completely 3D. So 3D drawing itself, it's the representations. Okay, it's in virtual representations. So when we have 3D model or model based, all definitions are there. So including how much is the gap in different part, what are the different tolerances, what are the specifications that material have. So when it is everything is placed in 3D drawings, and it is somebody has designed that one and sent it to other regions, they do understand because it's a consistent language. Okay, so that's the starting point of the virtual product development. So first thing, design itself, starting of the design itself, having in 3D models or 2D models, which is consistent across organization, it's in virtual starting of the virtual product development, where we can have information about aesthetic, assembly, and different components. Then moving to the verification portion, because here the simulation role is much more critical, because it started with verification of component, verification of different subsystems. So we should have that kind of a technical depth to have that kind of verifications. Previously, everything was to the lab, everything was through the prototyping. So, building the prototype, first thing, it's like we need cost. Second, we need time to build a prototype. And third thing, it's more or the person who is continuously working in that area. He has expertise, so it depends on the expertise of that person who is operating in that area, rather than understanding the physics. So tomorrow I'm working, say today I'm working on some component, and tomorrow if I'm giving to the some component to the other engineer who is quite new, so he has to start that journey from scratch. Okay, so transformation of knowledge or whatever he has learned, it's quite difficult to migrate to the new generations or coming or interfacing into the other world. So it's more your people centric approach, which was there with prototyping and testing with that one. Another limitations, in terms of physics, sometimes we just do pass or fail. We don't know if it is passed, whether we have over designed the product or it is just on the border. Okay, so considering all the variants, whether that product will again sustain, it will pass the required test or not, that we don't know. So for that one, again, we have to do testing on multiple component, use DFSS and see whether it is in that range, see the process capability. So it's quite tedious and time consuming, also cost. Okay, so that's what simulations is playing a vital role in the complete right side of verification role. Okay, so there is overall need of virtual product development. Moving to the next slide. Yeah, so first one, part of virtual development, as I mentioned, it is started with 2D and 3D modeling. So that's one vertical. So all designers, they are using multiple mature tools are there in market. So that's the first vertical. Second vertical of the virtual product development is simulations, where we do all kind of verifications. So the way we have, say, flow, thermal, structure, noise, or manufacturing, different capability we have based on that one. What simulation capabilities and integration of this simulation in product development, that's another vertical to drive this virtual product development. Third bucket is more your digital manufacturing. So digital manufacturing is mainly on the process, planning, assembly lines, even assembly line sequence, where to stop, which locations we can have multiple operations. So that kind of a digital manufacturing solutions can help us to drive the virtual product development. So in Whirlpool context, these are the major pillars. As per industry needs, there are different pillars that we can do it in virtual product development. Overall virtual product development means what we are serving. Because of virtual product development, what is happening, like we are getting first time buying product, okay, because we know in depth what is required. It is consistency in communication, so we know what is required from consumer, and also in terms of testing, we know we do understand the predictability of the product. So whenever we are launching the product through all simulations and going for the product development, it shows like first product is as per requirement. So it's that all iteration is reducing. So it's a first time right, reducing time to market because it's quite fast, at right cost because it's avoid a lot of prototyping, lab testing, and also the manual efforts on doing all these kind of things, and it's improve the productivity. So whatever the product we launch, uh, we know, we are quite confident about, okay, this product, it can perform in that range. So what is required to drive this virtual product development is moreover increase the implementation of virtual product development in virtual product design. So multiple people, they use the 2D drawing or 3D modeling, put all the engineering information starting with our tolerances, or when it is coming to the assembly, all stack up analysis, all these things we can directly integrate it in the integrated in the assemblies, so that things are much clearer in terms of product design itself. Increase the utilization of simulations, because sometimes some people, they believe, okay, simulation results are really matured, and we can direct without going for the testing, we can believe, we can understand what is coming out of simulations, and we can implement in the product. So as we increase more simulations, we do understand, and it can be a faster decisions. Use of AR and VR, that's a part of more your digital manufacturing. So how effectively we can do it in a simulation line, or different assembly sequence. So use of these tools, it will be really helpful. How we can do it? So developed high fidelity model. So it's not just developing the model, but the model should have the high fidelity, so that people should understand, or people should get, yes, whatever is there, I'm getting in test simulation is giving me the same results. So whatever outcome I'm getting out of simulations, whatever optimizations, or it may be some challenges, risk, I should mitigate those risks and work on those. Increase credibility of models. I'm going to talk about credibility in subsequent slide, but credibility in the sense, if you develop some model, it's not validated. Okay, you know its fidelity is not that high, and even the person who is utilizing that model, he know that credibility is not that high. It's good starting point for virtual product development. But when we have high fidelity model, and he knows, yes, we can replace some test, so we have that high credibility models. Sometimes what happens, we put a lot of efforts and develop some models, but the person who is using, or designer who is making the decision, he said the model is not that useful. So whatever the efforts you put in for developing that model, it's waste. So it's a wastage of efforts. Other side, you develop the model, you know the fidelity is not that high, means it cannot give the prediction for all kind of variations, that you know, and you are telling them, but still that person is using across all variant. So that's a misuse of model, or that's lead to the wrong decisions in the product development. So that's also a situation we don't want to take. So low fidelity model, low acceptance, yes, that's the starting point. High fidelity model, high credibility, in the sense that kind of a model means they should also pursue it, and they should use it for the virtual product development. Increase the adaptation. So use, try to understand what is there in the means what is the requirement from the test, understand the test properly, and how we can replicate the test, that's replicate the test, so that they can adapt the simulations, and reduce physical test and prototyping. Just click on this. So with virtual product development, we can have better quality product, faster and cost effective. Okay, so that's more your background of the virtual product development. Now let's come to some of the product development, what we have and how it is connected with the overall product development. Okay, so if you consider any product, start with refrigerators. What is basic intent of refrigerations? Core performance is maintain the control temperature in a closed domain. Okay, so when it comes to the requirement, it comes, okay, refrigerator domains, yes, it has to be say -20. RC, yes, it has to be -1 to say -5. CRISPR, it has to be say -2 to +2. So there are certain requirement, core requirement, correct? In terms of physics, how do you meet this requirement? It's more your, if you know very well how the airflow and thermal system is working, you with the thermal basic physics, you can understand and make sure, or you can predict the core performance. So what kind of a tool is required? The tool which we can simulate overall airflow and thermal, that tool can help to predict the core performance. Next product, dishwasher. So dishwasher, what is core requirement? Wash the dish. So core performance is wash and dry utensils. Okay, so there are certain parameters or KPIs we have in terms of measurement of wash core, dry cores. But in terms of physics, basic physics, it's water flow, how the water is impinging on the different dishes. Thermal, because it has some impact on washing, impact of overall washing, and chemicals. And it's a combination of all these things, how it is directly impacting on the core performance. Again, oven, cook the food, that's a core performance. And what is the basic physics? Airflow and thermal. Washing machine or dryer, it's more your wash the clothes or dry the clothes. What is the basic physics? How the water is circulated, how the air is circulated, how thermal and chemical reaction is taking place. So if you understand the basic physics, and with respect to that basic physics, if we can simulate it, that will predict the core performance of the system. Okay, and then you will really recognize where you are in terms of requirement of the consumer. Okay, moving to the next slide. So just connect to this one. So refrigerators. So when you have complete flow and thermal simulations, you do understand, okay, what is the airflow coming in different part of the system. So first, that is the first check whether the airflow is proper or not. Second, thermal simulation. It shows, okay, whether we are achieving the right temperature or not. Third thing, what we can get is like how much it is lost. Okay, so because of that one, it's an input for the energy model. So we can predict what kind of energy it can it's required to maintain the temperature. Okay. Same thing, dishwasher. If we are able to simulate, okay, with the spray arm, how the water is spraying on the different dishes, whether water is completely reaching, whether it is hitting or impinging at right velocity. That velocity is enough to create that much of shear stress. So all these things are coming from this dishwasher or water spray simulations. Then coming to the dryer. So means I know it's not that famous, but a bigger one is drum. Below side there is a fan, heat exchanger, and there is a heater. Okay, so whole thermal things we can simulate and understand. Okay, how the airflow is. Means first thing, whether there is sufficient air, where that air is properly covering the complete drum. Then with the help of heat exchanger, whether heat exchanger is properly taking out or reduce the temperature so that we can have the proper condensations, and to maintain again humidity and all these things so that we can absorb the moisture from the laundry where heater is effective or not, at what velocity it should be there. So all these kind of things we can do it with the help of simulations. So this is the power of simulations to visualize what is happening in the product. With the test, this is not feasible. Okay, that's what simulation is. Now it's we have more than last 20-30 years we have developed a lot, so I need not to explain, okay, what is how effective simulation is, but everywhere now we need to go for simulations to understand basic physics and making sure we effectively utilize it. Moving to the next one. So these are some simulation capabilities. So first one, if you see this structure, so this is an impact simulation. So we have to deliver the product to the customer homes. So it is starting from factory to the warehouse to stores to distributor to say maybe consumer house. So during this journey, we have to make sure it doesn't damage because of the way it is handling. So how we can do this kind of simulation? It's more your structure. So it's a product level simulations. So we are replicating, we're replicating multiple standard tests. Okay, so previously it was physical test. Okay, leave the product, say maybe 3 foots and drop it, leave the product, tilt it and drop, just leave it. So there are multiple tests, and all these tests now we could able to do it with the help of simulations and understanding which corner is facing the problem, which part is more or getting damaged. Okay, and then what can be the remedies or how we can reduce that kind of a risk. Below side, it's a washing machine, so it's complete fully dynamic simulations. So when it is spin with complete load, how overall dynamics, how much vibration it is coming out, and then how we can reduce it. Another vertical capabilities I already touched base is the flow and thermal simulation. So it is like first one is dishwasher, like how the water is coming on the dish, impinging on the dish, whether it's properly covering the area or not. So all kind of outcome that we can get it out of simulations. Next one is we get burner or combustion. That's another critical area, complex simulations. So whether flame is properly formed, emissions coming out of that one, temperatures, all this outcome we can get it from these simulations. Another critical is noise and vibration. So how much noise is coming out, because home appliances means all our appliances are at home, so nobody wanted to have higher noise. So and it should, and there are certain norms in Europe and North America region that noise coming out of these appliances, it should be in that range. And that's also another selling point. Also, because one of the source for noise is an electrical motor, so how much noise it can generate it and how much noise it is coming out of the appliances. So that kind of a source to path, and again, how it is come to the receivers. So that kind of a simulation we do it. Next one is regarding manufacturing simulations, where we do understand how the component is manufactured. So there are certain requirement in terms of aesthetics. Okay, there should not be any weld line. It should be like A surface, B surface, as per the aesthetic requirement. Also, there should not be any manufacturing defect to maintain the strength of the product. So all these things we are doing with the manufacturing simulation. There are certain injection molding simulations. There are certain sheet metal forming simulations. We do understand, and in early stage of design itself, we do the simulation. We are saying, okay, this is the way we should have the gate location. This is the way we should have the different operations in terms of forming. Okay, so these are glimpse of some of the simulation capability what we have. So which is helping us to drive the virtual product development. Moving to the next slide. So there are some complex simulations. Maybe you can click multiple click here. So first one, yes, just go back. Yeah. So first one in terms of complexity is combustion. So for cooking product, one is cooking where we have the gas combustions, and another one is dryer, which is gas fired dryer. Okay, so this type of simulations where whether flame is properly formed or not, because everything is in home, so safety and safety of this overall product is most important. So whether flame is properly formed, it should not come out. Also, there emissions should be in that control, CO, CO2, NOx. At what level flame is coming out, at what level it is lifting up. There should not be any issue like flashback, and whether it is maintaining the proper temperature what is required. So that kind of a simulations we do in terms of combustion. Again, in terms of multiphysics, this is an ideal example where we wanted to understand how much noise is coming out of, say, dishwasher, because there are spray arm, they are continuously impinging the water on the dishes, and even water is hitting on the walls of dishwasher inside. So because of that one, there is noise coming out of dishwasher. So how do you check that one? So what we did is like we carried out CFD simulations to understand what are the how the water is hitting on the wall. Overall pressure mapped in VA1, that is noise software, and then we see, okay, what is the response in terms of noise coming out of overall dishwasher. So this is ideal example of like how multi-domain and multi-physics is combined and addressing the consumer pain point. So it's not about just the capability we develop, but moreover how it can be the integral part of product development. Okay, so when we are saying it's an integral part of product development, in product there is always a variation. So how we capture this kind of a variation in simulation so that we can say the delivered product is a robust one. Okay, so this is one of the example where we use DFSS methodology, Six Sigma methodology. So optimize the overall temperature in the crisper. So which are the different parameters like fan speed? So there are steps on the back side, there are some steps, or there are certain gaps on the bottom side, front side. So we consider those gaps as a variable, and then we run DOE, study their interaction, which one is the better, and which is the parameter which interaction is impacting more, which parameter has a biggest impact, and then play with that parameter so that we can have a robust design in terms of virtual verification or virtual development. Okay, so it's not only capability, but using that capability in the product development the way we want. Okay, so that it can shows, okay, how robust is our product. So we talked about system engineering. We know like there are different subsystems and we can verify the performance of different subsystems. But when we combine two different subsystems, emergent, it's not the same as it is. So we have two different subsystems, but when we join them, not necessarily it will perform. Or when we are saying, okay, it is verified at two systems, we are quite confident about that subsystem. But when we combine and making it a system, emergent may not be as expected, because the kind of interactions we have with different subsystems it may be different, and that interaction impact has a some different outcome. That's what, to address the issue at consumer level or product level, we are coming up with the system performance modeling. So this is one of the examples where energy is one of the critical attributes. When we combine all subsystems and trying to understand how it is impacting the energy performance, so it gives the result at that level. Okay, so this is an example of electrical oven system. So what we develop is a system performance model. So whatever the models you have seen in previous slide, it's more your three-dimensional models. Okay, either it's a computational fluid dynamics, or it's a structural model, or noise model. So these models are modeled at very high accuracy. Okay, but when we wanted to understand the energy prediction, or we wanted to say temperature, transient temperature variation, it's not feasible in terms of time. Okay, because building this model, building all the complexity and running those model for the transient behavior, taking a lot of time. And if you want to optimize the solutions through the simulations, it will take more than 6 months to 8 months. And during that time, designer may say, I can develop the product, test it virtually, test it physically, and get the solutions. So to have this predictability in a virtual development, what we have come up with this system performance modeling approach. So what we did is, like, we are taking the output from the simulations. Okay, so either it's an response surface modeling, means we are taking the output in that way, or we are capturing the variation, for example, inner side heat transfer coefficient. So with respect to different temperature and flow rate, for a different component, what is the heat transfer coefficient? We are taking it from the CFD analysis, putting it as an input, and then putting and making sure that it's a lump model, which includes all the parameters, including heater, fan, cavity, different insulations, different ventilation system, even on electronics, which can give the fast solutions. Okay, so if you see, this is middle one is like system performance model, and outcome what we are getting is like temperature variation with respect to time. And also, if we discretize this system, not up to say very minute level, but high level, we can see what is the temperature variation, temperature variation across different component. Okay, but this is quite quick solutions. So these solutions are very useful for multi-objective optimizations. Like we wanted to say, I just wanted to change the capacity of cavity. Instead of say 30 cc, I wanted to go for say 35 or 40 cc. What is that impact? Which parameter I can change? What is change in overall space or changing capacity will impact the energy. At the same time, we have some cost model. If we change those parameter, cost model is taking into the considerations, considering different manufacturing aspect, and it shows, okay, if you change this component, what is the impact on cost? And then we can have a trade-off. Okay, if you want to go for say, some higher energy models, so I can increase the insulation. That is one of the simple things, or I can increase say maybe cycle time. Okay, what is that impact on energy? And at the same time, if I increase the insulation, what is the impact on overall capacity? What is the impact on a cost? That kind of a trade-off I can get in early stage of design. So if you see system engineering V, right side, we are quite confident. We can do all verifications, all these things. But how we can use this model on the left side so that we can have a right decision at architecture level. So this is one of the good example. So when you have the system performance model at attribute level, you can easily see, okay, because you don't need actually, means these models are developed because there are multiple products available in the market, but we wanted to say increase the range. Okay, and you wanted to extend the predictability to the different areas. So with help of these predictable models, what we can easily cross-check. So for example, energy norms is changing. So if you want to meet those norms, which are the different parameters we can play with? What is that cost impact on those parameters? And we can say, okay, if we add this much of cost, we can go to this class of energy. And if you have that class of energy, what is the overall business impact? Okay, and that way, overall business situations can be carried out with the help of system performance model. Also impact quick virtual verifications, eliminating multiple prototyping, and also we can develop system design tool. System design tool is nothing but to develop this model, we need an expertise. We need simulation tools. But once we develop this model, we can create an executable, irrespective of any software. This executable can be run by designers, so they can change the parameter and see the impact. Okay, if I change this parameter, what is that impact? So he can play with that one. So that's more your system design tool. Also, quickly, we do understand, means if there are, for example, thickness, what is the overall manufacturing variation, which are the different variations, all these variation we can capture, run the multi-kernel analysis, and we can see what is the strength and where it is lying, means in terms of confidence where it is lying. So that kind of all predictions we can do with the help of system performance modeling. Moving to the next one. So how we can speed up this journey? So, for any transformations, people, process, and overall ecosystem is most important. So in terms of people, we need competent people, and because this is continuously changing world. Okay, so we should have the proper strategy, and there should be a continuous competency development program. Either it's on job or learning and development. On job in the sense, make sure you continuously test different tools available in market. Make sure there are certain areas where you need competency development, you focus that area, and make sure people work on to develop the competency in specific areas. There are certain competencies which is available outside, maybe through the learning and development, or maybe calling the expertise from the other industries or academia. You can develop that competencies. Next one is process and tool. So there should be a proper KPIs for virtual product development. So we should know with the virtual product development, really it is helping us, at what extent it is helping us. Use the right simulation tools, use the process like Six Sigma, continuous improvement. Again, now machine learning is part and parcel of the virtual product development, how we use the simplified model and making sure it is useful for taking the right decisions. Also, simulation process, it's not only something we develop some competencies, how effectively and how quality results we are giving out of simulations, and data management. So that's the area in terms of tools we need to take care. And automations, because simulation, there are multiple steps where human intervention is required, but over time we know some of the areas which can automate and which can speed up the simulation process. At the same time, you should have the ecosystem. First one is hardware, because some complex simulations we need cloud, high performing competence. Then academics partnership. So for new skill development, where we cannot spend that much of time dedicatedly within our organization because of our projects and regular work. So maybe the academics, we have some good competencies in that area. So they can develop the competency as per our requirement, even hiring the right talent. So depending on your requirement, you can get a talent from that academia. Project collaborations or infra like labs and all these things that we can leverage with academia partnerships, and technical forum where you can leverage the best practices. Also, you come to know the different current trend, what is happening in the market. Okay, so this is the way we can speed up the overall virtual product development. So what is that impact? So already it's covered, like first time right, by understanding the product behavior, we are delivering the quality product. Go back. Reduction in overall product or reduction in product development time, reduction in physical prototyping. So day by day, in Whirlpool also product prototyping budget is going down. Multiple concepts evaluation at early stage of design. So optimized design with high confidence. And this also help us to accelerating the innovation because it's quick ideation to concepts. Okay, so this so first red line, it shows like, okay, initially we start with one concept, then we say, okay, it is properly or not, then we are evaluating it. So that's the traditional way of working it. But with virtual product development, what you call front loading, initial step itself, we are coming up with different concepts, validate the different concepts. Okay, then we get a directional results. So with that one, we are moving ahead. So rather than finding the error and again recorrecting it, come up with different concepts, evaluate in early stage of design itself, so that we know this is one of the best design which we are looking for, and go for the development. So that will reduce the efforts over time. So one is effort, second one is rework, third thing confidence. Okay, and also it will reduce your product development time. So future trend, so IoT, so digital twin, now everyone knows digital twin for product and process performance. Being in global organization, for example, we are doing some design work or development work in India. There are certain prototypes or something product, they tested it in test it in some other regions. So what is that testing performance? Which are the parameters they are looking for? If they vary the parameter, what is that impact? So if we have the replica of the machines and we can cross check it, so online also it's feasible. Okay, if I change this parameter, outcome is this is expected, but this is not coming. Then what is the correct reactions? Even virtual model itself can tell us, okay, change this parameter and make sure it's an optimized solutions. This is for design optimization also we can do it. This is for connected appliances, which is at say consumer home, where they use a different kind of load and wanted to see how I can optimize the laundry performance. So we can get the inputs. Okay, what is the load inside? What is the water quality? What kind of a detergent it is pouring inside that one? Based on that one, we can say, okay, instead of just going for limited cycle, we can adjust the program and say, okay, go with this program, which will give an optimum performance in terms of wash quality as well as the energy. So that's the power of more digital twin and IoT. Machine learning. So we also simulation also generate a lot of data. How effectively use that data so that we can have predictable model through the machine learning, either neural network or reduced order models. So all this part of that one. Mesh-free methods, because traditionally all simulations they developed based on FEA, FEM, or mesh control volume things. So new methodology is coming up, which is quite faster and which is mesh-free techniques. Also open source, because multiple people or community of people they are working so that at least basic design, basic simulations we can able to do it without investing anything. So but maturity of this open form now is day by day is increasing. So multiple organizations they use the wrapper just to use the open source course, use the wrapper so that they can having the simulation model for their required needs. And design tool, as I mentioned, designer need not to go for each and every simulations, but they have a design tool where they can just put the parameter and see what is their impact, and they can play with. And everything now is in moving to the cloud computing. So that's more on future, right? So what are the challenges? So I think somebody asked the question regarding what is the fidelity of the model. So um, that's most critical, because when we are predicting it, we have to make sure it is highly feasible, or it should replicate what is happening in actual test. Okay. Sometimes we go with point data, or some points we have taken. For example, now if you see the lines, we are point of verifications or point of validations. So if you take it 3 points, which is at the middle, and if you compare with the result, which is prototype or which is with the testing, so it shows it's more your replicating what is required, but actual variations are too big, and with that variation it is your performance is completely offset. So instead of just going for point data, for validation at least we should use that range of data, so that we should have that kind of a confidence that this model can be worked out for that complete range. Okay. Another challenge is simulation speed, because more detail you want, simulation is taking a lot of time. So you have to come up with methodology, what is required, what kind of a problem I'm solving, whether I'm using the right tool, and whether I'm using the right methodology to address the problems. And also risk of more focus on tool rather than technology, because some people they don't understand what is there in tool, what are the different assumptions while developing that tool, and they use the tool universally, and that is not a right use of tool. Okay. Software cost, hardware cost, and even the person working in simulations, so that capability person cost. So initially it's a high investment cost. That's one of the challenge. Then compatibility of multi-physics. So as of now, we have say simulations in one domain, but when we are addressing the performance at the product level, still getting multi-physics, it's a challenge. And we generate a lot of data, storing that data, manage that data, still it's a big challenge. Okay, and already I talk about like decision-making perceptions versus fidelity. If we develop some model and it says decision making, and we are saying okay, still fidelity is poor, so improve the fidelity. So we know we need to work on the model. But if you work on the model has good fidelity, but decision making perception is okay, that model is not good, then it is wastage of your efforts. But if you have the poor fidelity models, and if they use it for decision maker, or a decision maker use that model, then he may lead to a wrong decision. So we wanted to start with improve fidelity, and we wanted to be in context where we have good credibility in model where high fidelity is there and decision maker perceptions or adaptation from product development side is high, then we are landing it with the good credible model. So we have to get that credibility of the simulation model in product development process. Okay, so with that one, let me take a pause. So I'm ready to take the questions if anyone has.
Absolutely. Thanks a lot, Prafull, for this insightful session. We definitely have a lot of questions, and we also encourage our audience to keep dropping in their questions in the chat box to keep the conversation going. And for the ones who are asking for the presentation or recording of the session, please drop us a note to events at Zinnov. We'll keep you posted on the same. I think with that, Prafull, let's just get started with the question that we already have in hand, right? Before I have this question, like let's say there's a company who are just kickstarting on their journey, right? What are your 2 cents of advice because you've been in the system for a while now?
Okay, that's really good questions. So first thing, don't replicate what traditional companies are doing. So being in Whirlpool, because it's a traditional more than 110 years old company, still there are methods where they are going for say physical prototyping, physical testing, okay, and they believe in that one. So if you're going to start new company or new organizations, make sure how we can use this digitization transformation in early stage, because if you adapt it early, it's quite easy to maintain that one. But if you change what is, or if you adapt what is there, and if you start again changing what is required in market, that change management always takes a lot of time. So I would suggest uh, let use the latest trend available in a market so that we can adapt to the latest technologies.
Got it. Can you suggest how to choose the right tools and hardware with respect to our modeling requirements?
Okay, so it depends on what kind of a simulations you carried out. Okay, for example, CFD, when it is component level, then it is feasible that some high-end machine like okay, 8 GB RAM or 16 GB or 12 GB RAMs can support that one. But when it is come to subsystem or high-end simulations, we need hardware of that calibers. Means even normal system we cannot run the simulations. So depending on your need, at what complexity you wanted to get it and what level you wanted to solve the problem, based on that one you can choose either I should use for HPC or I should go for the cloud computing. And in terms of cost, because all this decision is based on the cost. So cost versus what is your need, based on that one you can select it.
Got it. Are there simulation mechanisms to identify or verify the longevity and the sustainability of the product?
Yes, because sustainability, if you see, just I mentioned packaging of the product. So as of now, we are using EPS, but now very soon we have to go out of means completely out of EPS. It should be an EPS free product. So how we can make it EPS free? So what are the different options? How with the simulations we can validate that one? Okay, and how make sure how fast you can adapt it to EPS pre-packaging. So that is one of the examples. Second example is like water consumption. So if you can reduce the water consumption or you can optimize the water consumption, that's also a good impact on one is consumer, reduce the water consumption at the same time, it is impacting the sustainability. So there are multiple areas, even in home appliances industries, as a sustainability, we are working on. I mean, one is that one, energy, EPS freeing, even different plastic components, how it discuss or how it is happening in manufacturing locations. These are the various aspects in terms of sustainability we can consider.
Do you develop simulation engines in Whirlpool or do you use commercially available engines or the library?
It depends. So most of the simulation, that is standard simulation like structural CFD. So we do use standard tools available in the market. But
Got
there
it.
are certain things like optimization, multi-physics, where as of now, nobody is directly helping us, or there are two different tools where we need to combine it. So means we use the different available tool in the market, but when it comes to the multi-physics integration, more or we need to do ourselves.
Got it. So you talked about, I think in the previous slide, you talked about the challenges that you oversee in the future for VPD, right? And how do you think these can be mitigated accordingly?
Okay, so first thing, people go with myths. Okay, so somebody is saying, okay, this simulation is required. So straight away, without understanding which area you need the technologies, what kind of a simulation that will impact your consumer or that will impact your product development. So first understand the need, and based on need, select the proper tool. Based on the need, select the fidelity. Okay, sometimes what happens, some people they are keep on working on the model development and making sure it has very high fidelity, and they use the model in early stage of design just to get some directional input. So if you want to just get a directional input, why do you want such a high fidelity model? It's good to have a fidelity model, but just for getting the directions, using the high fidelity model, in my opinion, it is a wastage of that efforts.
So Whirlpool does
Mm.
have a competitors in, let's say, LG, Bosch, Samsung. We can name a few,
Mm.
right? What are they doing in terms of the strategy? Like, how are they improving their product simulation? Do you have an idea in terms of what they are doing as well?
Okay, so in terms of simulation and product development, really speaking, I don't have, because LG, Samsung, both are Korean company and they have center only in Korea. So India, though they are manufacturing, but as such product development or R&D center, I don't think they are doing much work outside Korea in terms of simulations or product development.
Got it. Got it. So, what are the tools that you would suggest for the 3D model simulation based on your experience?
Okay, so there are different tools. So now, being in home appliances, because we are dealing with, say, cooling, heating, airflow, water. So that's a basic need for the core performance. So I would say use some CFD tools available in the market. Okay, so some people means their product may be completely structural. So they don't need CFD, they need some structural, correct? In structural also, like depending on the kind of product they have, accordingly they can select the right tool in the market. There won't be any universal tool which they can use across industry.
Got it. I think when you were showing us an example, it was a lot of these hardware products were there, right? Let's say refrigerators, dryers, so on and
Mm.
so forth. Uh, can you also let us know how the simulation can be used in software products?
I don't give you a question. Software product in the sense?
Software product developments are involved, right? So in those
Yeah,
cases,
correct,
yeah,
correct, 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 correct. So being on mechanical side, I know I got biased completely on mechanical simulations, but software, as I mentioned, complete verification and validations is doing from the centers, and there are multiple, and it's completely online. It's completely virtual. There is no manual interventions. Even touch button and their understanding touch button and their impact, they have developed the robot so that it is completely and virtual based. They can do it.
got it.
So in embedded, all software, even different cycle tool. Okay, so which cycle and whether that cycle is properly running or not. So everything is they do it. And when I'm talking about system performance model, it's physical model what I'm developing. Plus there is a control. So it's completely model based system engineering.
Got it. So there has been a constant frequent changes in the demand as well as there's a frequent changes in the technology that we have in the market, right? In those cases, how do you ensure that the back end compatibility of the stimulation devices are also on point?
No, it's we need to adapt. Means we need to be ready with whatever the technology available in the market. Because almost 18 years back when I started my journey, CFD tool was means it was quite like a buzzword. Okay, and it was just available at sub component level, or maximum we could able to do it at subsystem level. But over time, tool have improved so that we can improve the predictability. Second, hardware which is required for that one, it is continuously growing up. Okay, cost of hardware is a little bit going down in that sense, but availability of the hardware, it's going up. So because of that one, we can go up to the depth what we needed. Okay, so initially it was just flow thermal simulations. Now we could able to predict like in condensation, evaporation, which is multi-physics and quite complex. And as I mentioned about dishwasher noise, so there is an integration of like one tool, like CFD is running it, it is giving the pressure waves that is captured in say VA1, and they are using it for predicting the overall noise performance. So day by day, we are going in depth to understand how we can get the prediction of the product.
Right. As you were mentioning cost, I think cost is something that gets involved across the various things within the organization, right? So how do you get a business buy-in if you're going to start this journey? Because there's going to be a huge cost involvement in terms of bringing in this virtual product development, right? What are your 2 cents on that?
Yeah, so I will go with my example, because almost 15 or 20 years back when we started, it is started with some component analysis. So we do start with simple thing. This simple thing, if we do it, what is that impact? Okay, then we move to the subsystem level, and then we replace most of the test at subsystem level. And then now we are trying to replace at system level, where all system level, even some of the UL requirement tests, we are trying to do it virtual and trying to get that information. It's continuous journey. Means cost every stage we need to put it. Okay, when it initially started, it's just like one or two systems, one or two sort tools. The way we have shown it, shown the capability, shown the business case, and then keep on working on it. So it's continuous journey.
So, what are the simulation and modeling methods you follow for an electrical or a power electronics components and systems?
There are multiple, but frankly speaking, I don't have the expertise in that area.
Okay,
But EMI, EMC, even software testing, there are multiple things. Even itself can become the good session just to talk about electrical or electronics software.
got it. Thank you so much, Prafull. I think we still have few more questions, but we will take that offline with you.
Mm-hmm.
And that's it we have for you today. And it was an extremely thought-provoking session, and we had quite a bit of takeaways today. And it was an absolute pleasure to host you and to the ones who joined us today. Hope you found our today's session insightful. Thank you once again, and see you in our next Zinnov webinar. Take care and stay safe. Have a great weekend ahead.
Thank you, Zinnov team. Thank you, everyone. Have a nice day.
Thank
Bye.
you, everyone. Take care.